Hello everyone, welcome to the second part of the RTS tutorial series. On this part, we'll be creating the base building system for the game. So there are three types of base building system. The first one is the gridless base building system, or also known as the free build base building system. Now what it does is you can build buildings without a grid and you can rotate it however you want. The second one is the integer-based base building system, also known as the grid-based base building system. On this type, you can place buildings inside a grid which takes up your x and y values for the grid. And on the third type is the Raycast base building system. It's the same as the grid-based base building system, but what it does is wherever you are pointing anywhere, you can add an object to it, just like in Minecraft. But on this part, we'll be focusing more on the Raycast base building system. So without further ado, let's go into the tutorial itself. So first off, I'm gonna create a C# script and call it as the Raycast building system. Then I'll open it up with MonoDevelop. And on the inside, we'll be creating 5 variables. The first one is a transform, obj, or object to move. This is the object that we'll use and it will act like a cursor. This is where the object is pointing at. The next one is a game object to place. And then this one is the object that will be instantiated whenever we click the left mouse button. Third one will create a layer mask. We'll need it for the raycasting later on. And finally, 3 integers for the x, y, and z. Last pos x, last pos y, last pos z. Forgot to mention we'll also need the vector tree and we'll name it as the mouse position, mouse pos. Let's remove the void start method since we won't be using it, and let's head to the void update method. So on the void update method, we'll have to set the value for mouse pos. So the value of it would be the mouse position itself. That would be mouse pos equals to input that mouse position. Next, we'll create array, and I'll just name it as array itself. So array is a straight line from an origin and it has a direction itself. So the origin would be the position of our mouse. Now to translate the mouse position into a world point into the game, we'll simply just call on camera.main.screen point to array. So wherever we are pointing in this, we are translating it into array. Forgot to put this up there. Now we're gonna create another one, Raycast hit. I'll just call it hit as well. Now Raycast hit is a structure or a struct that gets information from array whenever it hits something. Now we'll create an if statement where we'll put all of the codes in. That would be if physics.raycast. Now Raycast needs 3 or 4 variables. That's the ray. Now the direction, that would be out and hit. And then the distance, that would be matf.infinity. Or you can just put 100. Depends on you. I'll just use matf.infinity. Now on the fourth one, we can add a layer mask in it. That's why I created the mask earlier. So let's just add the mask in there. Forgot to add another parenthesis. So now all of the codes will be inside this if statement. Now we want to get the positions x, y, and z, and the easiest way to do it is create a new int. It will be pos x equals to hit dot point dot x, and then the next one, the z value, int pos z is equals to hit that point at z. Now to see the position of our mouse in the game, we'll just simply use debug.log, and then let's just add like x plus pos z plus and z pos z. I'll save that up. Let's go back to Unity. Whoops, sorry. Let's change it to float for a while, and then let's test it. But first, we need to drag the script into the camera or anywhere. You can drag it on the plane itself or create an empty game object and place the script there. Now on the inspector, we need to set up the mask. That will be everything. Now let's leave the object to move and object to place empty for a while since we're not using it yet. Let's test it, and there you go. You can see on the console the position of our mouse, which is exactly accurate. Alright, cool. Now we don't want it in decimals since we need it as an integer, so it will act like it's in a grid. Alright, let's go back to MonoDevelop. Let's comment this out for a while, and then let's change this to int. But earlier we encountered an error since we cannot implicitly convert float to int, and that's true. So what we should do here is we're gonna cast it as an int. So casting is just like this, and then the next one we'll have to round off the value. value of it. So that would be mathf round, and then let's put this inside a parenthesis, just like that. I'll just copy it on the other one there. Now that we have that, let's create another if statement. If pos x is not equals to last pos x, or pos z is not equals to last pos z. Now the reason why I did this is because this is the only place where everything is updated, so it won't lag up our game. Now on this one, let's just set it as last pos x is equals to pos x, pos z is equals to pos z. There. Now let's create a debug.log, just copy it. Now instead of pos z, we'll just use last pos z, as well as on this one, last pos x. And let's try it out. And there you go. It's only updating whenever I move my mouse, and that will help us reduce lag in the game. But now we want to create like a cursor. So to do this, we'll just duplicate one of the cubes, move it back, and let's just create a new material. I'll just name this as the cursor. We'll change the color of the cursor to, let's say, green. Drag the material to the cube, and let's change the name of it. Let's say cursor. Alright, now on the main camera, let's drag the cursor and then put it to the object to move. There. Let's go back to monodevelop. Now below the debug.log, we'll just simply put object to move that position is equals to new vector 3. Now on vector 3, we'll need 3 variables, but we already have that, the pos x and pos z. We still haven't used the y position yet, but we'll tackle that later on. Well, let's just put pos x. Now on the y-axis, let's just put 0.5f, and then now on the z value, we'll just put pos z. There. Let's try it out, and there you have it. It's moving anywhere. But there's a problem with this one. It's a little bit fidgety whenever you move it, and it's like bouncing up and down. Now to do this, since we already have a mask, let's just select it and then remove the check on the cursor. And then on the cursor object, let's change its layer to cursor. That way it won't be affected by the raycast. And there. Now the next one is we want to place an object whenever we click the left button. So let's go back to the monodevelop and add it below. On this one, we'll just add an if statement and put input that get mouse button down. And then let's just map it to 0. 0 is like the left click of the mouse. Now whenever we left click, we're instantiating or spawning an object. That would be instantiate, and then the object to place, next the position. That would be object to move the position. The next one is quaternion rotation. We'll just put quaternion the identity, which means that it doesn't have any rotations at all. Let's save that up. Now on Unity, let's just create a prefab. So we'll use this cube or any of this cube and just drag it to the project. And let's go back to the main camera, drag the cube and put it to the object to place. And that's it. Let's test it out. Now whenever we click the left mouse button, it should spawn correctly. There you go. Now I know it's still not like an RTS. It feels like Minecraft or something, but we'll figure something out later. Now if you want to build objects above it, we'll simply just add a Y position for it. So let's go back to monodevelop. Below the int pos x, we'll just create an int pos y equals to just the same as above. We'll just copy it, replace the x with y. And on this one, we'll create another condition, pos y is not equals to last pos y. And then below the last pos x, we'll just add last pos y. I'm just gonna remove the debug here since we're not gonna use it anymore. And now on the object to move that position, on the vector tree, we're gonna replace the 0.5f and replace it with pos y, and we're gonna add an offset for it, which is 0.5f. And yeah, that's pretty much it. Let's test it out. Let's try building stuff and above it, and there you go. You can build above it. It's a simple system which you can use to create simple games. I'd say you can create like castle building game here, or anything, or maybe like a tower defense game like that. So on the next part of the base building systems, we'll tackle about the gridless base building system. So thank you guys for watching, and I'll see you next time.